Hello, this is Lewis, W3VVV, Whiskey 3, Victor, 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 demonstrating normal operation of a Kenwood TS-530S transceiver. I'm not going to go into any detail about the purpose of any of the controls or optimum settings of any of the controls. The main reason for producing this video is to show hams who have recently acquired a Kenwood TS-530S or similar rig, how the rig should operate when it is functioning correctly. So let's go ahead and get started. I'll turn the power on. The current VFO frequency will be displayed. I'm on a dummy load right now, so I can transmit without worrying about interfering with any other stations. You'll notice that on the top there's an RF attenuator, calibration, VFO, and processor light. With all of the push buttons out, the RF attenuator light should be off, calibrator light should be off, the VFO light should be on, and processor light should be off. If the VFO light is off, that means that the VFO is unlocked for some reason and that the rig has a problem, which means that the rig needs alignment and or repair or replacement of some components. Now let's go through the various controls. Audio frequency gain, AF gain, should go from 0 up through 10 smoothly. RF gain should go from 0 up through 10 smoothly. The meter should show approximately, should give an indication of the received signal level strength when RF gain is set to maximum. If you move RF gain down, then what will happen is the meter will actually start showing higher and higher and eventually get all the way pegged. So that is normal for this rig. Okay. So let's set RF gain back to maximum. And by the way, that what I just showed you with RF gain is true when AGC is set to slow or to fast. If you set AGC to off, then the meter will show 0, no matter what the incoming signal strength when you're receiving. So let's set AGC back to slow, set RF gain back to maximum, AF gain to some reasonable level. Going to go back on the dummy load. Let's go through the other switches. IF shift should move smoothly from approximately the 7 o'clock position to the 5 o'clock position. It should essentially lock in the middle of IF shift. There's a position where it will just stay in place. Going across here, mic gain should move smoothly from 0 up to 10. I'll turn the heaters on now, the heater switch on now. The heater switch, of course, turns on the filaments for the tubes. If the heater is not on, you will not be able to transmit. It takes approximately 15 seconds for the heaters to get to full heat output. So once you turn heater on, wait about 15 seconds before trying to transmit. Again, I'm transmitting it to a dummy load. I'll now do a test transmission. Mic gain is set to 5. ALC is the ALC display on the meter is set on. I'll do testing 1, 2, 3. Test, test, test. This is what we're seeing on the meter. You're not seeing a real lot of movement. If I turn on processor, you'll see that the meter will reflect the effect of turning on the speech processor. I'll turn the speech processor back off in a moment. You'll notice also the processor light came on up here. I'll turn processor back off and stop transmitting. Next control. I'll also show you mic gain, the effect of changing the mic gain. With the mic gain set at 2, I can talk pretty loud, and it really has essentially very little or no output. If I turn the processor on, I'll get a little bit of output. Hello, hello. Well, very little. I have to turn that mic gain up to about 3 before I really get much output. This is an MC50, by the way, a Kenwood MC50 microphone, which was the standard microphone that you could optionally purchase from Kenwood for use with this rig. I'll turn the mic gain up to 5. You can see the ALC kind of staying in the low ALC range. Turn up to 6, I get more ALC. 6 is probably about right for this microphone. With processor out. Keep going up to 8, and ALC kind of really gets toward the top of the range. So we probably don't want to really go beyond about 7 or 8. Turning mic gain all the way up to 10. Then we're sitting there really outside the ALC range, which is really shows that we have the gain set up too high. Let's turn the mic gain back to about 6, which would be about normal, again, as I said, for this situation. I'll release the mic keying switch. Let's look at some other settings here. Noise blanker switch should go smoothly in and out. Noise blanker has an effect only on pulse type noise, not on random atmospheric, static, and that sort of thing. Only on very even pulse type noise, such as automotive ignition systems, certain the noise from various electronic equipment that you might have in and around your home. So it is very effective for some noise and has no effect on certain other noise. Noise blanker level should go from 7 o'clock up to 5 o'clock and rotate smoothly. Vox, we are on dummy load. Turn on the Vox switch. That should activate the Vox. I'm talking, and the Vox does automatically kick the transmitter in. I could turn the Vox delay up all the way to maximum or all the way down to minimum. If I turn it to minimum, you're going to hear a lot of relay clicking as the transmitter kicks in and out. You can turn the Vox gain up to various amounts. There's the Vox gain, goes all the way from a maximum of about 5 o'clock all the way down to a minimum of 7 o'clock where the Vox isn't even triggered. Carrier level. Let's look at carrier level. Carrier has no effect. The carrier knob has no effect on sideband. No effect on sideband at all. So you can see here that if I, let's see, here, testing. All right, here I am on sideband. I set the carrier all the way up, move carrier all the way down, has no effect on sideband. If I go to CW, then carrier definitely has an effect. I will flip on the send switch, send some transmissions, or just hold the key down for a second actually, and you can see that as I move carrier, it affects the output level. Or here, I'll actually show. There's the relative output level, moving carrier down, and then moving it all the way up. We don't want to transmit really for more than a few seconds at a time. That at least send the continuous carrier for more than a few seconds at a time, because it's not really good for the tubes. Flip send receive back down to stop sending. Let's look at the various meter positions when we're transmitting. If we set, let's see, we can press the Vox button, and instead of flipping the send receive button, if we have Vox on, we can simply we can talk, and I'll turn the Vox gain up and the Vox delay up so that I can pause and not really have the transmitter keep and not have to worry about the transmitter kicking back off. And notice the ALC again is staying in the normal ALC range with mic gain set at 6. If I switch to plate current you can see varies and stays from about 60 milliamps and peaks up to peaks up to about 170 milliamps or so. Plate current is that very top scale where it says milliamps. RF output, that there's actually nothing on the meter really indicates anything about the actual amount of RF output. It's simply a relative reading, relative, relative to itself. So it's just kind of to show that, yeah, there's some output. All right, if you really want to see what your output level is, you should have a meter, an external meter that shows both averaging and PEP. Let's go over here. Let's go to CW and turn on send. Let's see, if we're set to ALC on CW, you should see absolutely nothing on the meter. Switch to plate current, that is IP. On CW, you should see about 70 milliamps, actually. That is normal. If we switch back to sideband and transmit, when you're not transmitting at all, the idle plate current should be 60 milliamps. You don't want it really higher than 60 milliamps for the idle plate current. Let's look at that idle here for a second. Okay, yeah, 60 milliamps. So you can control that. You control the idle plate current by setting a control on the back of the rig, and this is discussed in the manual. Let's go over here to high voltage display on the meter. High voltage normally should be about, looks like about 900 volts. That's normal. Same on CW, should be about 900 volts for high voltage. If your high voltage is much less than that, then you might have a you could have any of a number of different issues, not necessarily major problems, but that needs to be looked into. So normal high voltage is 900 volts. And let's see, going on here, let's look at just the different filters. Let's go to the lower sideband. We can press, if we press narrow, that I have the narrow sideband filter in here and a very narrow CW filter. So let's see if we can find something that's a good transmission to listen to compare this. If I press in the narrow filter when I'm on sideband, you should hear the audio essentially become narrower. Okay, on CW, now I'm not listening to a CW signal here, but let's see if we can find a good CW signal. Okay, there's CW signal. If I press in the narrow button, it'll give me this turns on my 270 hertz CW filter. Essentially cuts out everything except that very narrow slice of bandwidth. So all here is that one signal. If there were other CW signals adjacent to that, they'd be pretty much eliminated. So the narrow filter is very handy in a lot of cases. Let's go to the RF attenuator. We'll go back up to find some sideband signals. Here's with the RF attenuator in. Notice the RF attenuator light gets illuminated on the front panel up here. So RF attenuator turned back off again. Let's just see AGC again. Is AGC off? AGC fast, which is normally used with CW. AGC slow, which is normally used with sideband. Not sure if I showed RIT and ZIT, but here's the effect of RIT. tune 2.3 kilohertz up or down while not changing the VFO. XIT would do the same thing. Changed it back to the dummy load. If I'm transmitting, then I can change the transmit frequency up or down 2.3 kilohertz. The band switch should turn with definite clicks to different bands, smoothly but firmly. And let's see, now this will detune the rig, but just to, and I'm not going to demonstrate tuning up here. There's another YouTube video out there that demonstrates how to tune up a Kenwood hybrid rig. But if we adjust the drive control, there should be a position in drive where the signals are strongest for whatever frequency you have the rig tuned to. That would be a good starting position for when you're going to tune up the rig. Drive control should go all the way from about 7 o'clock to 5 o'clock smoothly but firmly. It should not, if you bump it, it shouldn't move. So it should be smooth but firm. Plate control should also be very smooth. It should be like silky smooth but slightly firm as I go around. It will rotate all the way around. And then the load control should also be smooth but firm. It will go from 9 o'clock to 3 o'clock for the load control. I think that's everything. So I hope this video has been helpful. Please make any comments. Thank you. This is W3VVV Lewis signing off.